Alright, so the first problem is a story problem, and it gave us words. And what we did was translate the words into symbols. The symbols that we used in chapter 2. And it's a conditional statement. And the conditional statement is such that the frets are perpendicular to the strings. Okay? So one of these frets is perpendicular to the string. Okay? So they're saying that this middle fret is perpendicular, or this middle string is perpendicular to this fret. Okay? Now, let's say that this is fret 1, 2, 3, and 4, and so on. Right? Now they want to know then how can you prove that these frets are parallel? So what we said is, if the fret is perpendicular to the string, then fret 1 is parallel to fret 2. That's what they want to know. So prove it. Okay? So that's the whole idea. So the way we're going to prove it is fret 1 is perpendicular to string 1. Right? And that's, what is that? What do we call that? Given. Fret 2 is perpendicular to string 1. What do we call that? Because it said it was perpendicular to all the frets, we can say that it's perpendicular to 1 and to 2, right? Okay? So what would that be? Given? Okay. Alright. Now, so basically we have another picture now. We're saying, hey, I got this and this, I got this transversal, right? Let's go with a different color transversal, okay? And I know that this and this are perpendicular. Now, it depends on what you use. I'm going to use something easy. I want to use what's called alternate interior. And because I want to use our congruencies. Because if we use supplementary, then we have to do minus and plussing and all that stuff, right? But if I do congruencies, so much easier. So our congruent ones, right? If they're parallel, then they're congruent. These are all those the alternate interior angles, alternate exterior angles, and corresponding angles. And you could have chose any one of the three. And what I chose was what? Which one did I choose? We know that they're alternating, right? Are these interior or are they exterior? Or are they both? Interior. Okay? So I chose alternate interior angles. You didn't have to choose that. I just chose it. So there's a lot of ways to do this problem. Okay? So what I'm saying is that string or fret 1 and fret 2 are parallel, right? Because of what? Alternate interior angles. And we're actually doing what the conv of that, right? Because they're saying if they're parallel, then they're congruent, right? That's the statement. But what we're saying is the opposite. Because they're congruent, then they're parallel. So that's why we're doing the conv of it, the converse. Does that make sense? Okay? So if you don't know what conv is, then write converse. Until you understand what conv is, write converse. If you don't know what AI angle is, then write alternate interior angle. Okay? Just like in chapter 1 when I said you're going to write segment, addition, postulate. Right? Until you get it and you understand it, don't write seg-pos. Okay? Alright, and that's it. We proved it. That was an easy proof.
Wait, don't write what?
Remember in chapter 1, it's hard when you're looking at your phone. That's why I'm not looking at my phone, even though my daughter's calling me and she needs me right now. Okay? In chapter 1, we were doing segment, addition, postulate.
Yeah.
Right? And so I would tell you in the beginning, I would say, write the whole word. And write all of it. Segment, addition, postulate. Until you know what it means. Okay? Alright. Alright, so number 10. What do they want for us in number 10? They want solve for x. Solve for x. Oh, they just want an inequality. And then solve for x. So what's the inequality we can come up with? Remember, if this side is perpendicular, then this side is perpendicular. And does that make a right angle? Is that a right triangle? All right, where's the hypotenuse? Is it x or is it 2x minus 5? Which one's the hypotenuse?
X. Wait, 2x minus 5.
Yeah. Always across is the hypotenuse. The hypotenuse is the largest side, right? So that means 2x minus 5 is greater than x. Does that make sense? The hypotenuse is always largest. So we're going to say 2x minus 5 is greater than x. And now we've got to solve for x. So how do I solve? Okay? And what is this? It's not quite given, is it? We have to actually, this is in chapter 1 when we're like segment, addition, postulate, right?
Isn't it the definition of a hypotenuse?
Yes. Good. Definition of hypotenuse. Okay? The definition of hypotenuse is it's the largest side, so therefore it has to be greater than anything else. Does that make sense? Okay? So the second step is what? This is when it starts to get easy. Because this is just algebra. Your basic algebra. Okay? So what do I do to both sides?
No, subtract 5. Oh wait, yeah, plus 5.
Plus 5. There you go. Okay. I would move the lowest x first, but sometimes that gets confusing for kids. Because then we leave a 0 over there.
Yeah, I was like, how would...
Yeah, so why don't we do it the other way? Just so you guys don't get confused with the whole 0 thing. You could do it this way, it works. But then you don't know which one you're going to be moving. Does that make sense? Always move the lowest x by doing the opposite. Does that make sense? So I'm going to subtract x from both sides, and I get x minus 5 is greater than x. Is greater than 0. Does that make sense? Because if there's nothing over there, then I have a 0. Right? What postulate is that?
Subtraction.
Yes. Subtraction.
Property of equality.
Property
Of equality.
of equality. Okay? I'm sorry, my bad. And then what do we do?
Plus 5.
Plus 5. Okay? And that's going to be
Addition, property of equality.
x is greater than 5, and then we have addition, property of equality, and we're done. Pretty Kate? Is it recording? Yeah. Alright, last one. Number 11. What does it want from us? So it wants the same thing. Okay? So, where is the hypotenuse?
9x
Good. So 9x minus 3 is smaller or greater?
Greater.
Greater than 6x plus 5. Why?
Definition of hypotenuse.
Definition of hypotenuse. Okay.
6x
Then what?
Wait, 6x plus 5?
Yeah, 6x plus 5. Alright, then what do we do?
So 4x.
Move the lowest x, right? Move the lowest x. What's lower, 9 or 6?
6.
Okay, how do we move it?
Minus 6.
So I get 3x minus 3 is greater than 5. What's that called?
Subtraction property of equality.
Subtraction property of equality. Okay? Alright, next. What do I do?
Plus 3.
Plus 3. So I get 3x is greater than what?
7 or 8.
8. And that's called,
Addition property of equality.
okay? And the last thing.
Divide by 3.
Divide by 3. Uh-oh. We came up with the fraction. Does that mean we did it wrong?
No.
No. Okay? So x is greater than 8 over 3. What does this mean? It means or. Why would I say or?
Because there's going to be another one.
Well, we could reduce it, right? 3 goes into 8 twice with 2 left over. So 2 2/3. Okay? And what do we call that? Division property of equality. And there you go. Better? I'll let you get that